The topic of this video is significant figures and their use in multiplication and division. Let's try using significant figures with a basic multiplication example, as shown here. When multiplying and dividing, we are limited to our least reliable or precise number. The phrase, "we can know the result of a calculation only as well as we know the least well-known value used in the calculation," holds true. So in the example here, we have 2, which is one significant figure, and 3,100 or 3,100 has two significant figures. So our least precise number is 2 with one significant figure. Now normally when we would multiply these numbers together, we would arrive at the answer of 6,200. However, because we are limited by our least precise number, 2, with one significant figure, this number is rounded down to 6,000, which also only contains one significant figure. In this example, we have 2.0, which contains two significant figures. Remember, this 0 to the right of a decimal counts as a significant figure, multiplied by 3,300. When we multiply these together, we arrive at 6,600, which has two significant figures, which matches both of our least precise numbers shown here. In this example, we have 2.00, which contains three significant figures, multiplied by 3,355, which contains four significant figures. Now, normally when we would multiply these together, we arrive at 6,710. And conveniently for us, our least precise number here has three significant figures, as does our answer. Now let's try this in a slightly more complicated equation where we're using dimensional analysis to figure out how many hours of work I would have to perform to purchase 2 sonars. This is an example used in a previous video. You may review that if this is confusing. So our equation here is 2 sonars times $3,000 per one sonar. The sonars will cancel in this case, and we're left with dollars, multiplied by 1 week per $500. Dollars cancel. And then multiply this by 52 hours per 1 week. Our weeks cancel, and we are left with hours. If we perform the algebra in this equation, we arrive at an answer of 624 hours. However, if you go through the problem, you'll notice that our least precise value has one significant figure. So the answer to this equation is technically 600 hours because we round down to simplify down to one significant figure. So you can see here that how many significant figures are retained in the values in an equation drastically impact the overall answer to any equation you're performing. And we only apply these adjustments to significant figures at the end of a calculation. This helps us avoid rounding errors and keeps answers consistent instead of changing within each of these fractions. In this example, we have very, very similar numbers. However, I've made slight adjustments to the significant figures in this value, this value, this value, and this value. Now, our least precise number contains 2 significant figures. So again, if we do our algebra, we come out with 624 hours. However, this time, our least precise digits have 2 significant figures, so this value is rounded down to 620 hours. In this example, now I've changed our values to have 3 significant figures. So if we perform our math out, we arrive at 624 hours, and because our least precise numbers contain 3 significant figures, our final answer can also contain 3 significant figures. Again, the differences between these examples show how drastically different the answer to an equation can be when proper or improper significant figures are used to describe things.